National Electrical Code Section 408.35 addresses panel boards, specifically those having more than 42 overcurrent protected devices. The core requirement is that such panel boards must be divided into sections. One or more adjacent sections of the panel board should be reserved for service equipment installation and must not contain branch circuit overcurrent protective devices. However, there's an exception to this rule. Service equipment is permitted in the same section as branch circuit overcurrent protective devices under specific conditions. Firstly, if the service equipment is installed in a separate enclosure, it's allowed. Secondly, if the branch circuit overcurrent protective devices are installed on a swinging panel inside a separate enclosure, it's also permissible. Considering the options of a 30-space panel versus a 42-space panel with a subfeed breaker, here's a breakdown. A 30-space panel inherently meets the 42 overcurrent protective device rule because it doesn't exceed that limit. However, it might not provide enough flexibility if future circuit additions are anticipated. A 42-space panel, when coupled with a subfeed breaker installed in a separate enclosure, also meets the 42 overcurrent protective device rule. Additionally, it offers greater flexibility for accommodating future circuits. Therefore, the choice depends on the anticipated future needs. If it's likely that more than 30 circuits will be required, the 42-space panel with a subfeed breaker in a separate enclosure is the preferable option. This arrangement ensures code compliance while providing ample capacity for future expansion. The key takeaway is the importance of the separate enclosure for the subfeed breaker when using a panel board with more than 42 spaces. This separate enclosure is what allows the installation to comply with the National Electrical Code and maintain safety. The panel board is a critical component of an electrical system, serving as a central distribution point for electrical power. It receives power from the utility company and distributes it to various branch circuits throughout a building. The panel board houses circuit breakers, which are overcurrent protective devices that protect the branch circuits from overloads and short circuits. When an overcurrent occurs, the circuit breaker trips, interrupting the flow of electricity and preventing damage to the wiring and equipment. Panel boards are typically installed in a readily accessible location such as a basement, garage, or utility room. They must be properly grounded to prevent electrical shock hazards. Panel boards are available in a variety of sizes and configurations to meet the needs of different applications. The size of the panel board is determined by the number of circuits that it needs to serve. The configuration of the panel board is determined by the type of electrical service that is being provided. There are two main types of electrical service: single-phase and three-phase. Single-phase service is typically used in residential applications, while three-phase service is typically used in commercial and industrial applications. Panel boards are an essential part of any electrical system. They provide a safe and reliable way to distribute electrical power to various branch circuits. Panel boards are also used to protect the branch circuits from overloads and short circuits. The National Electrical Code, or NEC, is a set of standards for the safe installation of electrical wiring and equipment. It's updated every 3 years by the National Fire Protection Association, or NFPA. Compliance with the NEC is mandatory in most jurisdictions in the United States. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It's essential for electricians and other electrical professionals to be familiar with the NEC to ensure that their work is safe and compliant. Article 408 of the NEC specifically addresses panel boards. It covers the requirements for the installation, wiring, and overcurrent protection of panel boards. Section 408.35, I previously mentioned, deals with the number of overcurrent protective devices in a panel board. This section aims to prevent overcrowding of overcurrent devices in a single panel board, which can lead to safety hazards and difficulty in maintaining the system. The exception to Section 408.35 allows for the use of a subfeed breaker in the same section as branch circuit overcurrent protective devices under certain conditions. This exception is intended to provide flexibility in designing electrical systems while still maintaining safety. A subfeed breaker is a circuit breaker that supplies power to another panel board or piece of equipment. It's typically used when the load is too large to be served by a single branch circuit. When a subfeed breaker is used in a panel board with more than 42 overcurrent protective devices, it must be installed in a separate enclosure, or the branch circuit overcurrent protective devices must be installed on a swinging panel inside a separate enclosure. This requirement is intended to prevent the subfeed breaker from contributing to overcrowding of overcurrent devices in the panel board. The separate enclosure provides a physical barrier between the subfeed breaker and the branch circuit overcurrent protective devices. This barrier helps to prevent accidental contact with the subfeed breaker, which could result in electrical shock. The swinging panel arrangement also provides a physical barrier between the subfeed breaker and the branch circuit overcurrent protective devices. The swinging panel allows access to the branch circuit overcurrent protective devices without having to remove the subfeed breaker. When selecting a panel board, it's essential to consider the number of circuits that will be needed both now and in the future. It's generally better to choose a panel board that has more spaces than are currently needed to allow for future expansion. The size of the panel board is also an important consideration. The panel board must be large enough to accommodate all of the circuit breakers that are needed. The panel board must also be able to handle the total load that will be connected to it. The load is the amount of electrical power that is being used by the equipment that is connected to the panel board. The load is measured in amps. When selecting a panel board, it's also important to consider the type of electrical service that is being provided. Single-phase service is typically used in residential applications, while three-phase service is typically used in commercial and industrial applications. The panel board must be compatible with the type of electrical service that is being provided. Panel boards are available in a variety of different configurations. Some panel boards have a main breaker, while others do not. A main breaker is a circuit breaker that protects the entire panel board. If the panel board has a main breaker, it will typically be located at the top of the panel board. Other panel boards have a neutral bar, while others do not. A neutral bar is a conductor that is used to carry the neutral current. The neutral current is the current that flows back to the source from the load. If the panel board has a neutral bar, it will typically be located at the bottom of the panel board. Panel boards are also available with a variety of different accessories. Some accessories include surge protectors, ground fault circuit interrupters, and arc fault circuit interrupters. Surge protectors protect the electrical equipment from damage caused by voltage surges. Ground fault circuit interrupters protect people from electrical shock hazards. Arc fault circuit interrupters protect the electrical wiring from damage caused by arc faults. When installing a panel board, it's essential to follow all of the manufacturer's instructions. The panel board must be properly grounded to prevent electrical shock hazards. The panel board must also be installed in a readily accessible location. The panel board must be protected from damage. Panel boards are an essential part of any electrical system. They provide a safe and reliable way to distribute electrical power to various branch circuits. Panel boards are also used to protect the branch circuits from overloads and short circuits. When selecting a panel board, it's essential to consider the number of circuits that will be needed both now and in the future. It's generally better to choose a panel board that has more spaces than are currently needed to allow for future expansion. The size of the panel board is also an important consideration. The panel board must be large enough to accommodate all of the circuit breakers that are needed. The panel board must also be able to handle the total load that will be connected to it. When installing a panel board, it's essential to follow all of the manufacturer's instructions. The panel board must be properly grounded to prevent electrical shock hazards. The panel board must also be installed in a readily accessible location. The panel board must be protected from damage. By following these guidelines, you can ensure that your panel board is installed safely and correctly. It is also important to consult with a qualified electrician to ensure that the panel board is properly sized and installed for your specific application. A correct installation or selection of a panel board can lead to safety hazards and equipment damage. Remember to always de-energize the electrical system before working on a panel board. This will prevent electrical shock hazards. Use appropriate personal protective equipment, such as gloves and safety glasses, when working on a panel board. Inspect the panel board regularly for any signs of damage or wear. Replace any damaged or worn components immediately. Do not attempt to repair a panel board yourself unless you are a qualified electrician. Contact a qualified electrician to perform any necessary repairs. Keep the panel board clean and free of debris. This will help to prevent overheating and other problems. Do not overload the panel board. Overloading the panel board can cause the circuit breakers to trip and can damage the electrical wiring. If you are unsure about the load capacity of the panel board, consult with a qualified electrician. By following these safety precautions, you can help to ensure that your panel board is operating safely and reliably. Furthermore, consider the specific requirements of the application. For example, a panel board used in a sensitive electronic environment may require additional surge protection or filtering. Panel boards used in hazardous locations may require special enclosures to prevent explosions. The selection of the appropriate overcurrent protection devices is also critical. The circuit breakers must be sized correctly to protect the wiring and equipment from overloads and short circuits. The circuit breakers must also be of the correct type for the application. For example, ground fault circuit interrupters are required in certain locations to protect people from electrical shock hazards. Arc fault circuit interrupters are required in certain locations to protect the electrical wiring from damage caused by arc faults. The installation of the wiring is also important. The wiring must be properly sized and installed according to the National Electrical Code. The wiring must be protected from damage. The wiring must be properly terminated at the panel board and at the equipment that it is serving. Proper grounding is essential for electrical safety. The panel board must be properly grounded to prevent electrical shock hazards. The grounding system must be properly installed and maintained. The grounding system must be inspected regularly to ensure that it is functioning properly. Regular maintenance is essential for the safe and reliable operation of a panel board. The panel board should be inspected regularly for any signs of damage or wear. The circuit breakers should be tested regularly to ensure that they are functioning properly. The wiring should be inspected regularly for any signs of damage or wear. The panel board should be cleaned regularly to remove any dust or debris. Any damaged or worn component should be replaced immediately. By following these maintenance procedures, you can help to ensure that your panel board is operating safely and reliably for years to come. Consulting with a qualified electrician is always recommended when working with electrical systems. Electrical work can be dangerous, and it is essential to have the knowledge and experience to perform the work safely and correctly. A qualified electrician can help you to select the appropriate panel board for your application, install the panel board correctly, and maintain the panel board properly. They can also answer any questions that you may have about electrical safety. Remember, electricity can be dangerous. Always take precautions to protect yourself from electrical shock hazards. Work safely and consult with a qualified electrician if you have any questions or concerns. Considering the nuances of subfeed breakers, it's helpful to understand their role in expanding the capacity of an electrical system. A subfeed breaker acts as a mini main breaker for a downstream panel. It's connected to the main panel and feeds power to a subpanel, which then distributes power to additional circuits. This arrangement is particularly useful when the main panel is nearing its capacity or when it's more convenient to group circuits in a separate location. For example, a workshop in a detached garage might have its own subpanel fed from the main panel in the house. This allows for dedicated circuits for power tools and lighting without overloading the main panel. When installing a subfeed breaker, it's crucial to size the breaker and the wiring appropriately for the load that it will be serving. The subfeed breaker should be sized to protect the wiring and equipment in the subpanel from overloads and short circuits. The wiring should be sized to carry the anticipated load without overheating. The National Electrical Code provides guidelines for sizing breakers and wiring based on the load. It's also essential to ensure that the subpanel is properly grounded. The grounding system should be connected to the main panel's grounding system to provide a continuous path to ground. This helps to prevent electrical shock hazards. When selecting a subpanel, it's important to choose one that is appropriately sized for the application. The subpanel should have enough spaces for all of the circuits that will be needed. It's also important to consider the type of loads that will be served by the subpanel. For example, if the subpanel will be serving motor loads, it may need to have a higher interrupting capacity. The interrupting capacity is the maximum amount of fault current that the subpanel can safely interrupt. It's also important to consider the environment in which the subpanel will be installed. For example, if the subpanel will be installed in a damp location, it may need to be enclosed in a weatherproof enclosure. The enclosure should protect the subpanel from moisture and corrosion. When installing a subpanel, it's essential to follow all of the manufacturer's instructions. The subpanel should be installed in a readily accessible location. The subpanel should be protected from damage. The wiring should be properly terminated at the subpanel and at the equipment that it is serving. Proper grounding is essential for electrical safety. The subpanel must be properly grounded to prevent electrical shock hazards. The grounding system must be properly installed and maintained. The grounding system must be inspected regularly to ensure that it is functioning properly. Regular maintenance is essential for the safe and reliable operation of a subpanel. The subpanel should be inspected regularly for any signs of damage or wear. The circuit breakers should be tested regularly to ensure that they are functioning properly. The wiring should be inspected regularly for any signs of damage or wear. The subpanel should be cleaned regularly to remove any dust or debris. Any damaged or worn components should be replaced immediately. By following these maintenance procedures, you can help to ensure that your subpanel is operating safely and reliably for years to come. Finally, remember that electrical codes and regulations can vary depending on the location. It's important to check with the local electrical authority to ensure that the installation complies with all applicable codes and regulations. A qualified electrician can help you to navigate the complexities of electrical codes and regulations. They can also ensure that the installation is performed safely and correctly. Electricity is a powerful force that can be dangerous if not handled properly. Always take precautions to protect yourself from electrical shock hazards. Work safely and consult with a qualified electrician if you have any questions or concerns. Understanding the nuances of overcurrent protection devices beyond circuit breakers is also beneficial. Fuses, for example, are another type of overcurrent protection device. They contain a metal wire or strip that melts and breaks the circuit when an overcurrent occurs. Fuses are typically less expensive than circuit breakers, but they must be replaced after they trip. Circuit breakers, on the other hand, can be reset after they trip. There are different types of circuit breakers, each designed for specific applications. Thermal circuit breakers trip when the temperature of the breaker exceeds a certain limit. Magnetic circuit breakers trip when the current exceeds a certain limit. Combination thermal magnetic circuit breakers combine the features of both thermal and magnetic circuit breakers. They are the most common type of circuit breaker used in residential and commercial applications. Ground fault circuit interrupters, or GFCIs, are designed to protect people from electrical shock hazards. They monitor the current flowing in the circuit and trip if there is a difference between the current flowing to the load and the current returning from the load. This difference indicates that current is leaking to ground, which could pose a shock hazard. GFCIs are required in certain locations, such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters, or SIs, are designed to protect the electrical wiring from damage caused by arc faults. Arc faults are dangerous electrical discharges that can cause fires. SIs monitor the current flowing in the circuit and trip if they detect an arc fault. SIs are required in certain locations, such as bedrooms and living rooms. When selecting overcurrent protection devices, it's important to choose devices that are appropriately sized for the load that they will be serving. The devices should be sized to protect the wiring and equipment from overloads and short circuits. The devices should also be of the correct type for the application. For example, GFCIs should be used in locations where there is a risk of electrical shock, and FCIs should be used in locations where there is a risk of arc faults. Regular testing of overcurrent protection devices is essential to ensure that they are functioning properly. Circuit breakers should be tested periodically to ensure that they trip when an overcurrent occurs. GFCIs should be tested monthly to ensure that they trip when there is a ground fault. SIs should be tested periodically to ensure that they trip when there is an arc fault. If an overcurrent protection device fails to trip when it should be replaced immediately. A malfunctioning overcurrent protection device can pose a serious safety hazard. Proper labeling of circuit breakers is also important. Each circuit breaker should be clearly labeled to indicate the circuit that it protects. This will help to prevent confusion and make it easier to troubleshoot electrical problems. The labeling should be durable and easy to read. It should also be updated whenever circuits are added or changed. Finally, remember that electrical safety is everyone's responsibility. Be aware of the potential hazards of electricity and take precautions to protect yourself and others from electrical shock and fire. Work safely and consult with a qualified electrician if you have any questions or concerns.